Hello everybody, my name is Rihanna Perez and I have a question. Are these materials solid or liquid? Yes! For example, different types of liquids. We have oil, juice, soda, dish soap, honey, and water. And for example, different types of solids. We have a microphone, a toy, an orange, cookies, and a bowl, and a spoon. So now we're gonna fill the cup. Well, liquids has three characteristics. Wet, flows, and takes the shape of the container or cup. So let's put water into this cup. So as you could see, this flows and takes the shape of the cup or container. So now let's put it in this cup, a different shape this time. So now we're gonna see what's happening. So let's pour it in there and let's see what's gonna happen, if it's gonna be the same as the other one. So as you could see, it flows and it takes the shape of the container or cup. So now for examples of the solids, I'm gonna use an apple. As you can see, I'm gonna put it in the plate and let's see what happens. So basically it's not happening nothing. It has its own shape and does not flow. So this is a solid. Now we're gonna wet. Let's see if the cup of water could wet, because that's the third one of the three characteristics. And let's pour it in and let's see what happens. So as you can see, it's wetting the paper. So now I want to know if salt is a solid or a liquid. So let's put it in this bowl and let's see what happens. So as you can see, this flows and takes the shape of the bowl. So now I want to know if we could wet the paper. So let's put the paper where the plate is. And now I'm gonna get a spoon of salt and let's see what happens. So as you can see, it's not wetting the paper. It's not wet. So a salt is a solid. Just because the tiny little pieces doesn't mean it has to be a liquid. It's just a solid. Like sugar and flour and so many things more. So that's all for today. Thank you. See you next time. Bye.
Breaking news. Have you ever seen a lava lamp? A lava lamp is made of liquids, but why don't the liquids mix? Today we will be seeing how liquids are different from each other. Like this water is clear, colorless, and also tasteless. It's also non-viscous. It's also polar. Polarity means it attracts positive and negative charges. Like this battery attracts this magnet. Another liquid is oil. Oil is a clear and it also has color, like this corn oil. It's also viscous and it's non-polar. And that's why water and oil don't mix. Some liquids are colorful, like this food dye. And that's why the three liquids make a lava lamp. So what happens if we add a solid to the liquid? But that's another show. Breaking news. Today I will talk about what makes a liquid different from another. To begin, there are liquids that are transparent, such as water. This means light can get through. And for example, the light could get through. So that means it's transparent. Others are opaque and translucent. Opaque is when no light can pass through it, while translucent will let light through, but you can't see clearly through it. And let me demonstrate it by pouring our juice in. And as you can see, the light could get through, but you can't see it clearly. And for our other one, we have our milk. And as you can see, that the light cannot get through. So that means it's opaque. Liquids are also different because of viscosity. This is how slow it can flow. Let's see how slow honey will drip. Unlike water that can flow pretty quickly. And we're gonna do this. And as you can see, it was very slow, so that means it was viscous. And we have our shaving cream right here. And so that means that it's foamy because it's soft and it's made out of teeny tiny bubbles. For our last one, we have soda, which is bubbly. This is Gavin Mercado, Terence Reilly News reporting.
Hi, my name is Haley. Today we are going to do an experiment that will show how does a liquid change when it is heated or cooled. Just like anything else, a liquid is made up of tiny particles called molecules. In our experiment today, we will be using water. Water is a liquid that is made up of 3 particles. 2 of them are hydrogen and 1 is oxygen. Water is known as H2O. When the water is heated, the molecules start to speed up, causing a thermogenic effect. This is why the liquid is hot when heated, because molecules are moving fast. When the water is cooled, the molecules slow down and stick together as the temperature goes down. The water starts to form into a solid called ice. Water becomes ice when the temperature reaches below 32 degrees. In my experiment, I'm going to boil water. You will see the water bubble as the temperature. In my experiment, I'm going to boil water. You will see the water bubble as the temperature rises on my thermometer. The bubble in the water are the molecules moving fast as they are heated. Now that the water is hot, I'm going to cool it down with ice. Watch as the temperature on my thermometer goes down and the water stops bubbling. These are the molecules slowing down. These are the molecules slowing down. This concludes my experiment on how a liquid changes when it is heated or cooled. Bye.
Hi guys, welcome to Maria's Science Lab, and today we are going to do a science experiment for the science fair. And we are going to be working with solids and liquids. For the liquids, we have water, oil, and vinegar. For the solids, we have baking soda, coffee, and ice cubes. Today I'm going to be working with vinegar and baking soda. We're going to see what happens when you mix these two. As you guys were saying today, we were using different types of liquids and solids. We learned that there's different types of liquids and solids. And we're going to mix vinegar with baking soda. But safety first. You're going to be using vinegar and baking soda and see what's going to happen. Let's put the baking soda first. Baking soda. Oh, that's a lot of baking soda. And now let's put the vinegar. As you guys saw, when we mix a liquid with a solid, sometimes it turned into gas. In this case, it turned into gas because of the chemicals reaction from the vinegar and the baking soda. The chemicals reaction makes a gas, and the chemicals that make that reaction is sodium and carbonation acid. Hope you guys liked our video for the science fair. We answered some of the questions for school. Terence and Reilly. Bye!
Hi, my name is Matthias. So we're gonna do experiments. How does a solid change when it's heated? So we have ice, butter, and chocolate. Now we're gonna heat it in some pots right over there. So now we're pouring the ice and see what's happening. So it's melting and it's turning into a liquid, as you can see. It's slowly shrinking. Now you can see the ice is liquid. It's like water. Now we have butter. But remember, you always need to have a parent with you. The butter is melting really fast. And it's really steaming. You can see it's turning to liquid. It has more liquid than the ice. Same thing with the ice, it's shrinking. Now it's a liquid. The liquid is kind of yellow, but it has a lot of bubbles. Now you know what happens when the butter is heated. Now we have chocolate. It's a solid because it's not really melting that fast. As you can see, it's just melting a little by little. It's melting slower, but it is melting. As you can see, it's melting. Now it's fully melted, but it's burning a little because we waited a little too long. Now you know when a solid is heated. Bye!
Hello, boys and girls. Mia here. Have I got a super cool project for you today? I'm going to teach you how I learned how to make a rainbow with sugar and water with my trusty assistant. And we dissolved the sugar and water on the stove, and in order to create different densities, we mixed different amounts of sugar in each color. Here we have yellow 0 sugar, red half a cup of sugar, green 1 cup of sugar, blue 2 cups of sugar. I'm going to be using a syringe to collect 5 milliliters, which equals 1 teaspoon of each color to create my rainbow. Here we go. So first, you get 5 milliliters of your blue.
3.
So now we're going to collect 5 milliliters again for our green. And squirt it in very carefully. Try to make sure it doesn't mix. Slow and carefully squirt the rest of the green in. Then you're going to take more water, squirt it out, and then do the red. 5 milliliters. Again, squirt it in carefully. Then you take more of your water and do your yellow. So you needed to do the same thing for the yellow and carefully squeeze it in like all the others. So now, as you can see, I put it over a light. Can you see? And you can see that the blue and the green didn't mix. Different densities didn't allow the colors to mix. I hope you enjoyed the lesson. See you again on Mia's Quest for